Hi everyone, welcome back. In this video, we'll be looking at how to use truth tables to determine the validity of an argument. In the last video, I explained how you can use Venn diagram to determine the validity of an argument, and I iterated that there are solid relationships between set theory and propositions. In fact, when you are talking of sets, the principle of working out sets is more or less that of what? Proposition as well. And I made mention that when you are using set A, B, C, so A, B, C, which is an uppercase letter, denote a set. Likewise, you can use an uppercase letter to denote proposition as well. Propositions A, B, C. Likewise, I said when you are talking about union of a set, that is the elements in A or B or both, that is union of A and B. So then you'll be talking about disjunction in what? Disjunctions in what? In proposition or logic. So then when you are talking about your intersection, so then you will be talking of conjunction in logic. So likewise, if you are talking of complement, for example, when I say complement of a set A, that is what elements are in the universe set that are not in A. So then you'll be talking of a similar term in what? In logic, which is called negation. Recall negation of a proposition is true when its truth value is what? Is false, and it is false when otherwise. So likewise, when we are talking of is a subset of, so then here for proposition, so we will be talking about implies. That is your if then, that is this is set, this is proposition. I hope you understand now. Then and I told you that you can as well use your Venn diagram, to determine the validity of an argument. In essence, recall that when you want to when you want to define or you want to establish test set using your Venn diagram, recall we use our square or rectangle to denote what? To denote your universe set. Y set are denoted by a circle. For example, if I now have another set, so inside this set, then I can say that this is my universe set. This is my universe set. Let's say this is set A and this is set B. Then here we can say B is what? It's a subset of A. Similarly, you can do the same for what? For proposition. Let's say I have my universe set, which is like square. Then you have like a proposition here. You have another proposition. I hope you understand now. So then if this is your universe set, and this is proposition A, this is proposition B. Then from there, we can conclude adequately that B implies A. So I hope I've stated that. Then another thing I want you to take note is, I said that in logic, which is the study of reasoning, we have two types of reasoning. The first one is what? Inductive reasoning. Inductive reasoning. Then we have also deductive reasoning. And I told you when you proceed in your study of mathematics, you are going to do what we call mathematical induction. So when we say inductive reasoning, it's a type of reasoning whereby our conclusions is based on observation. Whereby conclusion is based on observation. For example, now let me say, okay, now Gafari come to Katin to buy amala at exactly 10 o'clock. Maybe you observe that I used to call, I come to Katin to buy amala at 10 o'clock. Maybe you've observed it for like 5 days. And at the end of the day, you now conclude that, oh, Gafari used to come to buy amala at what? At exactly 5 o'clock, 10 o'clock in the morning. So you will see that this lack generality because it might be the case that maybe when you were there, maybe by just coincidence, that was when you noticed me, you observed me. It might be the case that I comes at other time different from 10 o'clock too. So when you have this type of reasoning, we call them what? Inductive reasoning. That is when you base your conclusion on H, on observation. When you base your conclusion on observation. So, but when we say deductive reasoning, so deductive reasoning, it's more of reasoning we used in the last video. So that is the process of showing that a certain statement are accepted as true. I hope you understand now. So in essence, in your deductive reasoning, all the possibilities you have been exhausted, and therefore you just come into what? Into a generalized conclusion. Let me give you an example. When you say eh, all chicken lays egg, all chickens lays egg, and you still have another premises that says birds. Okay, let me say all chickens are bird. All chickens are bird. Or you say chickens are bird. Then another statement, all chickens fly. If you connect the two together, I can come into conclusion that what? All chicken lay egg. I hope you understand that. This is what I'm trying to say. Chickens are bird. Then I now have what? All birds lay egg. This con implies that what? Chickens also what? Lay eggs. I hope you understand now. We come into a conclusion by what? From a set of possibility that has occurred that it is true. So in essence, I now made mention that when you are talking of an argument may be described as a set of what? Proposition. That is set of premises. When you have proposition one, proposition two, proposition three, for example. So they are set like this is known as what? It is known as argument. So which leads what? This argument now leads to a conclusions. So this argument leads to a conclusion. And a valid argument is one which all the premises are true. In essence, when you have your P1, conjunction P2, conjunction P3, I hope you understand now. So implies C. You understand? When you are using your hand, as connective, it means before you can say they are true, it means all the proposition or premises must be true. So it means when you take this guy now, if this imply this, then you must have what we call tautology. I hope you understand now. So, and I told you if an argument is valid by, virtue of this property, then you said it is what? It's a valid argument. It's a valid argument. Otherwise, it is not valid. We just call it a fallacy. We call it a fallacy. So, and I describe how you can actually, use Venn diagram to determine the validity of an argument. But in this video, I'm going to explain how you can use truth tables to determine the validity of an argument. At times, you can have a more complicated argument. For example, now the one that you might not be able to use your what? Venn diagram for, then in that particular case, it is advisable to construct your what? Truth table. So as I'm going to show it to you, so it is advisable to construct your truth table. What are you going to be constructing there? So for example, now when you have set of premises which are your argument P1, P2, P3, I hope you understand now. So then you are now going to connect them together. Recall if I say if P then Q, so it means P implies Q. Then you're now going to connect them together. I hope you understand now. So when you now connect them together, you can express them in what do we call it? In your symbolic form, that is truth table. So for example, if I have P implies Q, then I now have P divided by Q. This is a premises, and this Q means a conclusion. Then you can rewrite this in what? In symbolical form. It will now be the same thing as what? P implies Q, eh? And P implies what? Implies Q. Don't worry, you will get the explanation. Okay, now let me give you an example to back it up. Example, example. The question says, write the argument below symbolically. That is, you want to write it symbolically, you want to use your what? You want to use your logical operators and so on. So, argument below symbolically and determine whether the argument is valid. Don't forget what I said before we can say it is valid. That is when you take the conjunction of your propositions, of your premises, of your hypothesis, and you now you assume they implies your conclusion. If you have a tautology, then you will say it's what? It is valid. Let me give you an example. Let's say the first premise says if tortoises eat well, if tortoises eat well, then they what? So they live long. You know, it's a premise, it's a set of proposition because we have two propositions there. Tortoise eat well is a proposition. Then they live long is another proposition. Then the second premise is what? So the second premise is so tortoises tortoises eat well. You know, we have second premise now. Then I told you if you now have a line, then what follows after the line is known as your what? It's called the conclusion. And what is your conclusion here? Tortoises live long. Okay, let us check it together and let us do it. So, if you want to determine the truth value, you follow these steps because for us to write it in an argument, this argument, you know, these are argument set of premises. Before we can write it symbolically and determine whether it is what it is argument or not, it means we have to put in what a truth table. How do you do that? You can say let A represent what? Maybe the first statement, tortoises eat well. You know, this is a statement. Can you still tell me another statement we can derive from this? Yeah, it is obvious. They live long. You know, this is like if, then this is like P, or this is like A. They live long is what? It's also like B. Can you? We can also have. We can also formulate another statement. Can you tell me? So, think of it. It's supposed to be tortoise eat well, but we formulated it before. We don't need to formulate that again. I hope you understand now. So we don't need to formulate that again. Okay, now let us now continue. Look at the first premise now. If tortoises eat well, then they live long. Okay, how do you write that symbolically? How do you write that symbolically? You know, we can say, okay, let's write the argument now. You know, the argument is set of the first premises will be what? A implies B. Is that not so? A implies B. That is, if A happens, then B will also happen. If tortoise eat well, then they will live long. I hope you understand now. So then we still have another proposition now, another premise now, that is tortoise eat well. So now we now assume that A happens. You know, the first one is that if A happens, definitely then B also what? B happens. So and the next premise we have is that A happens. I hope you understand now. And we now have our conclusion. So your conclusion is now what? uh Tortoise live long. That is B also happens, which is your B, then we have B apples. So then from that you confirm. Don't forget now, our if you form like a conjunction of true premises, we have true premises now. Okay, let us form them together, join them, conjunction. uh So before you can have like an argument, you have to what? Take the conjunction of the premises. This will now be A implies B, which is the first one. The second one is or and, that is the conjunction A, that is A happened. I hope you understand now. Then for your conclusion, it means it implies, what is your conclusion now? B. I hope you understand now. So it implies B. Let me explain again. The first one is what? If A happens, then B. That's the first one. We can rewrite it logically like this, Abi. So then the second premise is A happened. Then your conclusion, I said you just draw your line down and write it. B happens. So if you now want to combine them together, or you want to show that these are valid, it means when you take the conjunction of these premises and now you say it implies your conclusion. If you are able to show that they are tautology, then it is valid. If it is not so, maybe it is contradiction, then it is not valid. It's mere a fallacy. So that's why I say the first one, A implies B, and A implies B. Okay, now let us now draw our truth table. Now we have like two proposition. Don't forget what we used to do. A, B, A, B. What do we still need? A implies B and A, right? And lastly, A implies B and A implies B. I hope you understand now. At the end of the day, if we have this last line to be tautology, it means that is a valid argument. So if you are doing that, what we are doing is we are writing it symbolically. Let me draw the line very well so that it makes more sense. I hope you are following. Don't worry, you will understand it. I will give you more example now. I want to use a straight line to make it better. Oh, good. Okay. Since we have what? Since we have two statements, it means we are going to have how many possible truth value? Four possible truth value. That is true. Don't go ahead. That is true raised power to this T T F F, right? True, false, true, false. And don't forget, this means A implies B. I told you when you have your connective to be an implication, the only time you are going to have false is when the first property is true and the second, when the first proposition is true and the second is false. Otherwise, they are going to be true. It means true, true is true, true, false is false. If you've forgotten, please refer to my previous videos. You are going to find my explanation on that. False, true is true, false, false is also true. I hope you understand now. Then now we have to marry this guy. That is A implies B and A. So that is this guy with this guy. Sorry, this guy with this guy. Don't forget, and the only time you are going to have true when you combine them together is when they are both true. So it means true and true will be true, false and true will be false, true and false will be false, true and false will also be false. I hope you understand now. Then likely lastly we can now say this and this implies this. Don't forget your implication. The only time it's going to be false when you have the first proposition to be true and the second to be false. Okay. True, 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 false, false, true, false, true, true, false, false, true. I hope you understand now. What can you conclude? You will see that our symbol now, our argument now gives a tautology. So you now conclude by saying since, can you see it is very simple? Since A implies B and A implies B, which is our conclusion, is a tautology, then the argument is what? Then the argument is valid. Then the argument is valid. So, and we call this type of argument, yeah, this type of reasoning a direct reasoning. What did I call it? Direct reasoning. So, direct reasoning. You can see it is very direct reasoning because if tortoise eat well, it lives long. You know, there are no like complication there. So, or you can call it modus ponens. They may ask you in your what? In your objective, so that you get it correctly. So let me give you another example so that you understand what I'm trying to say clearly. Example 2. Determine determine whether determine whether the following argument is valid. So so the following argument is valid. Number, we have the argument like this. Let me write it in another marker. If Abdul like chemistry, you know this is a premise, right? Then, or let me say a statement, then he passes the course. This is another statement, but the combination of this is a premise, that is a proposition, a compound proposition for that matter. And the second premise is what? Abdul does not pass the course. You know, this is not direct. We call this type of argument or this type of reasoning indirect reasoning or modus lens. I'm going to explain better. And you also have another what? Then immediately after that, uh you have your conclusion now. Recall I told you the moment you have your what? The moment you have line drawn, it means your argument is done. So what you have left there is your conclusion. And your conclusion here is therefore, 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 Abdul does not like chemistry. I hope you understand now. You know, you have your premise one. If I were you, you can just denote that. First of all, check all your statements. Number one, solution now. Solution. You can say let P, your statement P. What is statement P? Be what? Let statement P be Abdul like chemistry. I hope you understand now. So statement P means Abdul like chemistry. Okay, can we still derive another statement? Okay, yes. Q. So what will be the statement Q now? Statement Q will be he passes, sorry, he passes the course. Can we still derive another statement? We don't need to because you can see that even Abdul does not pass chemistry, pass the course. You can, use negation to do that. I hope you understand now. So, okay, now what will now be your first premise? What will be your first premise? You know, from our argument, if Abdul like chemistry, what is Abdul like chemistry? That is P implies he passes the course. That is Q. I hope you understand now. And what is second premise? Second premise is what? Abdul does not pass the course. Abdul does not pass the course. You know, he passes the course is Q. Does not pass the course will be what? Negation of Q. I hope you understand now. Then from that, you can have we have conclusion after that. What is our conclusion? I said you are going to draw a line. Then immediately after line, what follows is your conclusion. Abdul does not pass the course. So Abdul does not pass the course. So what is where is Abdul? You know, Abdul. This Abdul. He passes. Abdul like chemistry is your P. So and Abdul does not, sorry, therefore Abdul does not like chemistry. That's the conclusion. Abdul does not like chemistry. That will be negation of what? Negation of P. You know, we said P to be Abdul, Abdul like premises. That's why we call the negation of P, Abdul does not like chemistry. You know, we do that. Okay, now, so you can see that this is an argument. You now have it in an argument form now. Are you getting that now? We have it in an argument form. Okay, now can you write it symbolically? You know, in symbolic form, since we have two proposition like this, what do I ask you to do now? Just combine the two premises together. So then we have P implies Q. I hope you understand now. This will now be and negation Q. So then for conclusion, before you have your conclusion, you still have implies negation of P. So then if you are able to show that this proposition, so if you are able to show that this proposition is a tautology, then we have like a valid argument. That's what you're asked to do there. You know, it is not difficult. Okay, now let us show it in our truth table. Let me tell you what I did before. For your argument, if you want to find your argument, that is, it will be that all your premises are what are true. And before they can be true, don't forget, before we have true two statement to be true, it means you must have used your conjunction between them. That is, you use and between them. Okay, now let us now try it. I have P, I have Q, P and Q, right? Then I can have my negation Q, because I want to marry this guy with this guy. Then I can now have what? P and Q, P and Q, and negation Q. And lastly, P implies Q and negation Q implies negation of P. Oh, it means I need negation of P too. Let me rewrite it in such a way that it will, I can create more space. Okay. In fact, you can, from here, you can have negation P, negation Q, P implies Q, P implies Q and negation Q, P implies Q and negation Q implies what? Negation P. You know what I've done is I've broken them down into pieces. Then you can draw your line like this. You can draw your line this way, this way, this way. You have something of this nature. Okay, now immediately you've done that, since we have two propositions, then what is going to happen? So we have four possible truth value. Then you put true, true, false, false, true, false, true, false. I hope you understand now. So what is negation of P here? That is false. Negation of P, false, true, true. Negation of Q, false, true, false, true. Then your P implies Q now. Don't forget, for implication, you can only have false when the first is true, the second is false. So it means true, true will be true, true, false is false, false, true, true, true. Then implication and this. You know, and the only time you are going to have when you are using and conjunction, the only time you can have true is when both of them are true. It means this and this, false, right? False and true, false, false and true, false, true and true is true. Unlikely, this guy, let me change my marker. This guy, this guy now with what? With negation of P. Implies negation of P. Don't forget your implication. The only time you can have false is when the first is true and the second is false. Okay, false, false, true, false, false, true, false, true, 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 true. Can you see? You can see at the end of the day we have what? Tautology. So it means your argument is valid. How do we know it is valid? Because our symbolic form we were able to show that it is AH, it is a tautology. So then you are now going to say, therefore, since P implies Q and negation of Q implies negation of P is what? Is a tautology. Then the what? The argument is valid. So the argument is valid. And what type of reasoning is this? It is indirect reasoning. So this type of reasoning is called indirect reasoning. Do you know why? Indirect reasoning. Because you can see we were told that Abdul like chemistry, he passes the course. Then we were still told that Abdul does not pass the course. I hope you understand now. So you know it is what? It's an indirect reasoning, which is also known as modus tollens. What did I call the first one? That is the direct one, that is modus ponens. Please take note of them. Let me give you another example so that you get it very well. And you know how to convert like a symbolic form to argument form now. Like for example, now if I have symbolic forms like this, you know I can convert it to an argument form too. So, okay, I have, what do I have here? You know, it's going to be P implies Q. That's the first premises. The second premise is what? Negation of Q. And then, so your conclusion will be here. So that's that. Maybe asked to convert a symbolic form. So to what? So argument form, or from argument form to symbolic form. That should not be a problem. Okay, let me give you the last example so that you get it correctly, because you can have different, I've done the one on the direct reasoning, we have indirect reasoning. So you can have a transitive reasoning too. So whereby we use scale rule. So in that sense, you have three what? You have three propositions. You can derive three propositions from it. Okay, let's check. Determine whether the following argument is valid. How do you know it is valid? That is, when your argument, that is the conclusion, the conjunction of all the premises implies the conclusion. I hope you understand now. Okay, and the argument is this. If you study my video, or let me say, if you watch my video, if you watch Math with Logas video, if you watch my videos, then you will be guru in math. You'll be a guru in math. That's the first premise. If you are a guru in math, then you will go to a university. You will go to university. You go to university, and you now have a line now. It means your argument, you are done with your argument. This line represents your what? Your conclusion. Therefore, if you watch my video, if you watch my videos, then you will go to university. Can you see now? Let us determine whether these arguments are valid or not. So let us determine whether these arguments are valid or not. What are you going to do? The first thing to do is to represent, the pairs of the proposition. Number one now, I can say let P be what? Is watch my video. Or let me say you watch my video. You watch my videos. Then what will be your Q now? That is, you can derive another statement. Another statement will be what? You be a guru in what? In math. Even we can still see another statement, check it. The next one, if you are a guru in math, that is, with that is also Q. You will go to a university. It means we can still have our another statement to be what? You go to university. That's the third one, fourth one. Okay, now can you now write this? This is what? Can you write it symbolically now? Or let me say in an argument form. So if you watch my videos, that is P, then implies you are a guru in math, Q. That's the first what? First premise. Okay, now. Okay, we can still rewrite the second premise. We can still write the second premise. So how do we write the second premise? If you are a guru in math, that is Q, then then means implies you will go to university. That is R. You will go to university, that is R. Then after that is your conclusion. Don't forget, the moment they draw line like this, it is your conclusion. This is a symbolic form. Sorry, an argument form. Okay, now what is your conclusion? Therefore, if you watch my video, if you watch my videos, that is, you watch my video P, then implies what? So you go to university, implies R. We call this type of argument a what? Or reasoning, a transitive reasoning. And don't forget, when you get to higher level mathematics, you are going to study what we know as what? So order. So we have the different sorry, we have relation. We are going to learn what we know as relation. We have a reflexive relation. We have a symmetric relation. A reflexive relation is when you relate an argument, or let me say a proposition with itself. So a symbolic symmetric relation is that if you relate A with B, and it means it's the same thing as relating B with A. You understand now? So, and the transitive one is that, like the one you are looking now, if P relate with Q, Q relate with R, it implies P relate with R. I hope you understand now. So this is my what? Symbolic argument form. So we've written it in argument form. Okay, now can you write it in symbolic form now and test whether that argument is valid? Don't forget your argument, you are going to take them together. That is P implies Q, and Q implies R. I hope you understand now. And Q implies R. So after that, this conclusion means implies P implies R. I hope you understand now. So if you are able to show that this is a tautology, then what does that mean? So it means that that argument is valid. Okay, let us try it now. We have like three propositions. We have three propositions. We have three propositions. Your P, your Q, your R. P implies Q, Q implies R, P implies R. I think that's all. Then we have what? P implies Q and Q implies R. Let me write it very well so that let me rewrite it so that the place can occupy it. Let me make my writing smaller. So we can have from here, just break it down. P implies Q, P implies R, Q implies R. The other is immaterial. Then we can have P implies Q, and Q implies R, implies P implies R. No, this before then. So let's take this. Then after that, we can have P implies Q and Q implies R. implies P implies R. I hope you understand now. If we are able to show that the last one here is a tautology, then the argument is valid. Okay, let us draw our line. Let us draw the line. So then this is going to be P for Q for R for P implies R for Q implies R, and lastly for this. So then let us draw my table. Okay, now can we now continue since we have three propositions? It means we are going to have 8 possible truth values. 8 possible truth value. This is going to be true, 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 false, 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 right? Right. Then true, true, false, false, true, true, false, false. And this is going to be true, false, true, false. If you've forgotten how we derive this, please refer back to my previous videos. True, false, true, false. So true, false, true, false. I hope you understand now. So then the first one, P implies Q. P implies Q. Don't forget, the only time you are going to have false is when you have true implies false. So true, true, that is true, true, false, false, true, 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 true. I don't need to waste my time because we know that already. Okay, now what will be your P implies R? P and R. The only time you are going to have false is when you have true, false. This is going to be true, false, true, false, true, 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 true. Okay. Q implies R. This guy and this guy. The only time you are going to have false is when the first is true, the second is false. True, 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 false, false, true, true, false, false, true, 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 false, 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 true, true, false, false, true. Then you are now going to marry this guy together. P implies Q, Q implies R. Let me change my marker. P implies Q, Q implies R. True, true. And. And don't forget, the only time you are going to have true when you are using conjunction is when both are true. True, true, that is true. True, false, 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 true. Check it out, false, true, true. I hope you understand now. And lastly, you marry this guy, implies this guy. Don't forget implication. The only time you are going to have false is when the first is true and the second is false. True, true. I think with this guy, let me say true, true. We have true. False, false, true. False, true, true. False, true, true. False, false, true. True, true, true. False, true, true. True, true, true. True, true, true. You understand now? Interesting. Très bien. So then we can see that what we have, our symbolic form gives a tautology. And I say therefore, since P implies R and R implies Q, implies what? P implies R. I hope you understand now. Is what? Is a tautology. Is a tautology. Then what happens? What can you conclude? Then the argument is valid. And what type of argument is that? So, or what type of reasoning is that? We call it transitive reasoning. In some textbook, they call it what? Chain rule. We call this chain rule. In fact, when you get higher, when you have transitive, you understand now. We can call it a chain rule. So, or you call it rule of syllogism, or what? Syllogism rule. So you may be asked this rule in your question. They are not difficult. So they are not difficult. I hope you understand now. So I hope you understand now. If I were you, I would just go back to my past question. and what? And check the related question and solve them. If you have any problem, you can come back so for advice. So, but before I complete my video, don't forget I said we have like a direct reasoning. So we have like an indirect reasoning and we have like a transitive reasoning. I hope you understand now. So that is the three forms of argument you have. So the first one, if you have P implies Q and P, if it gives you what? Q, so that's what indirect reasoning, which is the same thing as if you want to write it in an argument form, P implies Q, P, then your conclusion is Q. So that is direct. Then the second one, which is indirect. So, in symbolic form, you have P implies Q, because they may ask you what type of argument is that, so that you are able to give them a good answer. P, so then you have what? If you want to write this in argument form, this will be what? P implies Q, Q, therefore P. I hope you understand now. And lastly, you can have a transitive argument, so or transitive reasoning. So this is going to give me what? When you have P implies Q and Q implies R, if this implies what? Implies P implies R. So, and how do you write this in an argument form? That is P implies Q. So Q implies R. Therefore, conclusion, P implies R. You can see it is very simple. So this is direct, indirect, and this is what? Transitive, or you call it the law of syllogism. So if you understand this video, please don't forget to like, share, and subscribe. I will see you in the next video. Thank you.